So this video lecture is about polymorphism, and polymorphism is a very powerful feature of object-oriented programming, and it is built off of inheritance. So when you have a hierarchy of classes, we understand from our exploration of inheritance that it allows us to save code, it allows us to define related objects in a hierarchical and abstract way. But polymorphism is also based off of a hierarchical structure. So whenever we have inheritance involved, we can further save code and we can make a method behave in a different way depending on the kind of object that's passed to it. So this behavior of a method where it can morph into different form is what gives polymorphism or multi-forms its name. So we will just take a look at how it is done. But the important thing to keep in mind in polymorphism is that this is a feature which works because of the way we have the ability to pass a child object wherever a parent object is expected. What do we mean by this? So we mean two things. First of all, let's say we have if you remember from our animal class, we know that, let's say we have dog inherits from animal. And so therefore we have animal and then we have dog here. We know that we can have a declaration of the type animal A equals new animal. We know this. But what we also can do is we can say animal A is equal to new dog. So we can declare an animal to be of a certain type, but we can actually create it to be of a child type. So declare of parent type, but create a child type. The reason why this is, if you're interested in knowing the mechanics of how this happens, know that A is just a pointer to the child object. And we can absolutely do that. But we need to be careful. What we cannot do is we cannot say dog D is equal to new animal. So we need to keep in mind that when we do the declaration, the order is important. And if this is the order, then we can declare something to be of this type and create it to be of this type, right? So once we understand this, then we will be able to use this feature when we create a formal parameter to a method, because this is the kind of association that happens when. So if you're able to have the declaration animal A is equal to new dog, then if I have a method, let's say I have a public static void some method, a method, then what I can do is I can say I'm expecting an animal A here, and what I would like to do is do animal A dot make sound right here. And if this is my main program, if this is my main method, what I can do here is I can say pass to a method the object A. And the reason why the compiler is fine with this is because you are passing something of type A, and therefore the type matching occurs perfectly. But what we are actually passing here is something which is created of type dog. And in reality, A is a dog, and that is getting passed into this. And then the dog's make sound method is going to get called. But we have to be really careful that the make sound method exists in the animal class. If it does not exist in the animal class, then this feature is not going to work. But what actually does happen is if make sound method exists in animal class and it's overridden by the dog class, then the make sound method of the dog class gets executed. And that's what gives the polymorphic behavior, because if I had another animal, B is equal to new bear, and then I said A method B, then the bear is going to get passed in. And so the first time round, we had the dog's sound. So let's say this was bow wow. And the second time round, this was the bear's sound, that was growl. And therefore this method, A method, is potentially take in different animals and execute the different sounds of the different animals. And that's what makes it polymorphic. And all of this is possible because we are able to be consistent with the formal parameter. The formal parameters of type A, these animals have been declared to be of type animal but created of type dog. What is also possible is that we can still do dog D is equal to new dog, and we are able to pass this and say A method D, and this will also work because dog inherits from animal. But the reason why polymorphism works is because this kind of declaration, declared of the parent type but created of another type, this declaration is passed by the compiler at this point, and therefore it's also passed by the compiler when we use it as a formal parameter. And this is the kind of assignment that happens when you pass a child object into a box where you expect the parent object. And it's not actually passed by value, but what's actually happening is addresses are passed, so reference is passed. But a reference of the type animal A equals to dog is absolutely fine. We can do something like, for example, if A is an animal of type dog, we can absolutely do, A is equal to D, where A is equal to B, where A and B both have been declared to be of type animal, right? So this is the background of why polymorphism, the mechanics of polymorphism, and why polymorphism works. So let's take a look at an example here. The animal class with polymorphism. So what I have here is I have created several animals here. I have 3 dogs and a tiger. And let's say I have a method called make advertisement clip, in which I would like to basically display the advertisement for whichever animal. Now, the reason why polymorphism helps to save code is if I did not have polymorphism, then what I would end up doing is I'd need to make a make advert clip method for each and every animal that I have. I would not be able to reuse the same method regardless of whichever animal. And I'm able to do that because I've got this feature where I can pass any animal which inherits from the animal class, right? So let me not do the zoo at the moment, but just do make advert clip. So here if I do make advert clip, and then I create an animal, D, as you can see, make advert clip. Let's run this. So here is the cell spiel. My name is Buddy and Bow Wow. So I have passed a dog into make advert clip. As you can see, it is of type declared of type dog, created of type dog, and I've passed it to the make advert clip method, which is expecting an animal, and it is able to take as a runtime. This is a runtime activity that's happening. It's able to dynamically bind this formal parameter to an actual parameter, which is of type dog, and print this is the spiel, and then print the a.sound method. The important thing to understand is the sound method needs to exist in the animal class for it to print the dog sound method. So the dog sound method is overriding the animal sound method. Now let's pass another animal, and let's say maybe pass the tiger T here. So as you can see, I can pass animals of all different types because my method can handle all the generic animals. So as you can see, my name is Sher and roar happens. So what I have saved here is I've saved myself. If I had 500 animals, then I don't need to make 500 make advert clip methods. But what I can do is I can just have one method and take in any generic animal, but sneak in the actual animal which inherits from this generic animal class, and that will work. Another feature also is that if I had, for example, wish to put all of these creatures into a single array or a single database, then as we know in Java, you need to give the type of the element that's going to be stored in the database. And we can't have an array of, dog and tiger and cat and mouse, but it needs to be of a single uniform type across, either integers or doubles, where every element is of the same type. And so if we have various animals of various creatures and we would like to put them together in a single database, then this kind of declaration is very useful, because what I'm saying here is I'm creating an array of animals, but when I do the actual assignment, I can assign them to individual specific animals, which are child classes of the animal class. So I can create a zoo in which is an array. All these elements of the array are of type animal, but they're all created as dog or tiger or different animals. So this is a remarkable thing that polymorphism allows me to do. And what I can now do is, instead of individually calling this advert for each animal, I can just pass the entire zoo, and then here I can just loop over, and when I do AI.sound, it will individually call the sound method of all of these animals. So let's run that and see how that happens. So as you can see, it goes through each of these animals in turn and calls, and then it just calls that the sound method. If I mute the sound method of animal, if I do not have the sound method of animal, then the point is, even if I have the sound method for dog and the sound method for tiger, then polymorphism will not work, because it thinks that what's coming in is an animal and it will only accept those methods that belong to animal. So this should give me a compiler error. So as you can see, it says cannot find symbol. So we have to be aware that if we are going to do polymorphism, then only those methods can be called inside a polymorphic method that belong to the parent class or belong to the type that's declared in the formal parameter of that method. But at runtime, dynamic dispatch is going to take place and overriding will happen, and the child class method will override the parent class method if that's what needs to get done. There's one more thing that I wanted to mention about casting, is that if we, in the same light, if it looks pretty restrictive that you cannot, inside a polymorphic method, call a method that is specific to a child class, you have to stay only with the methods of the parent class, then we can use the casting feature if we are sure that what's coming in, for example, is a tiger, we've declared it to be an animal, but what's coming in is a tiger, then we can force a tiger method to happen, right? Even though we know that hunt is not part of the animal class, but it's part of the tiger class, then, but we know that the third element is a tiger, we can force it to happen by saying, oh, I've got an array of animals, but the third element I know is a tiger. I can cast it to tiger and call the hunt method. Casting always happens at runtime, and we are assuring the compiler that I know, I happen to know, and you don't need to do any type checking, and I'm going to take care of that. So as you can see, let's run this. Let's run this now and see. You see, here it says I'm hunting deer, and this method is, hunt method is what's actually getting called. Now, let's say that I do this for A0. A0 actually is a dog. And what I'm doing here is I'm saying, oh, I know what's coming. What is in A0 is a tiger. Then the compiler is going to trust us. And when we run this program, then we are going to get an exception, right? Because it says dog cannot be cast to tiger. And it turned out that we are trying to call a tiger method and convert a dog into a tiger, which is just not possible, right? So we have to be careful with that. And there is also a instance of. So instead of getting this, one way to get out of this exception situation is to check and see if this object is actually of the class tiger, so that we will be sure. We can say call the thing, else we can say else system dot out dot println that this is not a tiger, right? So we can do that. In fact, we can say tiger, and we can print and system dot out dot println it is an x dot getName. So let's try to run this. So here it says this is not a tiger, it is a dog. So, so this is another useful thing that we can do to determine inside a polymorphic method, or in fact in any method. You can use the instanceof method to check if the class of the object is of the type that you're checking. For example, in this case, tiger. And then you can also check the class of the object by using the getClass method and get the name of the class as well.